Module 8.2. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 8.2. How can we numerically describe quantitative data? Part 2. Looking at the central value of a variable is not enough to fully describe it. We also need to talk about how spread apart the values are. Just like there are different ways to describe the center of a data set, there are different ways to describe the spread of a data set. The range of a data set is the largest value in the data minus the smallest. The range is a very simplistic measurement of the spread. Percentiles break the data into 100 parts. The pth percentile is a value such that p% of the observations fall below the value. Quartiles split the data into 4 parts. Q1 identifies the bottom 25% of the data. We can think of Q1 as the median of the lower half of the observations. If n is odd, we exclude the median when finding Q1. Q2 is the median. Q3 identifies the top 25% of the data. Think of Q3 as the median of the upper half of the observations. If n is odd, we exclude the median when finding Q3. The inner quartile range, or IQR, is equal to Q3 minus Q1. The IQR is the preferred method of measuring spread when the median is a measure of centrality. Any larger number than Q3 plus 1.5 times the IQR, or smaller than Q1 minus 1.5 times the IQR, is considered to be an outlier. The 5-number summary of a variable is the minimum, Q1, median, Q3, and the maximum. The standard deviation and variance tell us about the spread of the data. Data that is tightly packed together will have a small variance, and data that is spread far apart will have a large variance. The formula for the standard deviation, when calculating from a sample, is given in the notes. We will not calculate the value by hand, we will use software. The important thing is to realize that the standard deviation measures the typical distance from each data point to the mean of the data set. The variance s squared is equal to the standard deviation squared. So if we calculate the standard deviation, the variance is easy to get. When we calculate the standard deviation from a sample, we use the symbol s. When we calculate the standard deviation from population data, we use the symbol sigma. The formula is slightly different. Notice if you are using an online calculator to calculate standard deviation, make sure to check if you are working with population data or sample data. Standard deviation is the preferred method of measuring spread when the mean is the measure of centrality. We will look at the variable sodium in the serial data set. First, notice there are 77 different serial types in the data set. This tells us that there are 77 types of cereal in the sample, and that little n is equal to 77. The values of the variable sodium, listed from smallest to largest, are located in the script. To find the range, the smallest value in the data set is 0, and the largest is 320. Therefore, the range of the variable sodium is 320 minus 0, which is equal to 320. Quartiles. The easiest quartile to find is Q2, since Q2 is the median. Previously, we looked at the sodium observations arranged from smallest to largest. We found that the median was 180. Next, to find Q1, we want to find the median of the first half of the data set when the data is arranged from smallest to largest. Highlighted in green is the first half of the data set, excluding the median since n is odd. The middle data point occurs between 125 and 30. Therefore, Q1 is equal to the average of these two numbers, which is 127.5. This tells us that 25% of the data falls below the value 127.5. Alternatively, we could say that 75% of the data falls above 127.5. We could do the same thing with the upper half of the data to find that Q3 is equal to 215. Summarizing, we have the following. To find the IQR, we take Q3 minus Q1, which gives IQR equal to 87.5. The 5-number summary for this data set is as follows. One thing to note is that most software will calculate the median in the same way. There may be some differences in the calculation of Q1 and Q3. Do I have to calculate the values by hand? No. There are many ways to calculate the range, 5-number summary, and IQR. You can use an online app such as the one given in the script, or you could use software like Excel, SAS, or R, or many calculators will also calculate this for you. The 5-number summary can be visualized with a box plot. Box plots are plots of the quartiles of the data. They can help us spot outliers. Vertical lines are drawn at Q1, Q2, and Q3 with a box formed around them. The box represents 50% of the data. Horizontal lines are also drawn out from the box to the largest and smallest non-outliers. Outliers are denoted with a dot or other small symbols. Located in the video script is an additional video with an informative example of a box plot and quartiles. Looking at the sodium example, again, notice there are 77 different types of cereal, and that tells us that little n is equal to 77. Previously, we found the 5-number summary and the IQR. When first creating a box plot, you want to check for outliers. As a reminder, any number larger than Q3 plus 1.5 times the IQR, or smaller than Q1 minus 1.5 times the IQR is considered an outlier. Located in the video script are each of these values. Looking at these values, we can see that we do not have any data points from the sodium data set larger or smaller. Therefore, there are no outliers. Here we have a box plot of the variable sodium. This output was generated using a statistical software named Minitab. Looking here, we can see that we have vertical lines at Q1, Q2, and Q3 with a box around them. Located inside that box is 50% of the data. Then we have vertical lines extending to the smallest and largest data points. And notice we were able to extend all the way out to the smallest and largest data point because there were no outliers in this data set. Are quartiles the only way to partition a quantitative variable? Recall that quartiles split the data into 4 parts. There's no reason for us to stop at 4. We can split the data into any number of parts we want. Some common partitions are given below. Quartiles split the data into 4 parts. Quintiles split the data into 5 parts. Deciles split the data into 10 parts. And percentiles break the data into 100 parts. For this course, the 2 most important are quartiles and percentiles. We've already discussed quartiles, and now we will discuss percentiles. Percentiles of a data set divided into hundredths or 100 equal parts. The pth percentile is the value of a quantitative variable which is greater than p% of the data. It ends up that the quartiles can be written as percentiles. Q1 has 20% of the data below it, therefore Q1 is the 25th percentile. Q2 has, same as the median, has 50% of the data below it, therefore Q2 is the 50th percentile. Q3 has 75% of the data below it, therefore Q3 is the 75th percentile. We will again look at the sodium variable. Suppose I want to find the 20th percentile of the data set. In other words, I need to find the data point which is greater than 20% of the data. To find the 20th percentile, we can do the following. Write the data in order. Calculate how many points will be lower than 20% of the data set. Find the data point greater than the lowest 20% of the data set. For this example, there are 77 data points. To find out how many points are in the lower 20%, we can calculate 0.2 times 77 equals 15.4. We cannot find 15.4 points, so we round this number up since we want the point greater than the lowest 20% of the data. Located here is the data set in order. The smallest 16 data points are shaded blue. Looking at the table, we can see that the value of the 20th percentile for this data set is 90. Why is the standard deviation important? The standard deviation gives a rough estimate of the typical distance of data values from the mean. The more spread out the data set is, in other words, the more variability there is in the data, the larger the standard deviation will be. Comparing the two plots, the top data set will have values that are close to one another, in other words, smaller standard deviation, and the bottom will have values that are further apart. In addition to calculating the standard deviation, it's important to know the properties of the standard deviation. The standard deviation measures the spread from the mean of the data set and should be used only when the mean is the measure of centrality. S equals 0 when all the observations have the same value and there is no spread. Otherwise, it is strictly positive. S is sensitive to outliers because the formula for standard deviation depends on the mean, which is also sensitive to outliers. S has the same units of measurements as the original observations. The standard deviation can help us compare the values of different variables. For an observed value of a variable x, the corresponding value of the standardized variable z is called the z-score of the observation. Z-scores are useful because they put variables on a common scale. A negative z-score would indicate that the observation is below the mean. A positive z-score indicates that an observation is above the mean. A z-score equals 0 indicates that the observation is equal to the mean. The z-score is a measure of relative standing. For instance, a z-score equals to 3 indicates that the observation is larger than most other observations. The formula for the z-score is located in the video script. Example: an incoming freshman at UK took the placement exam in Spanish and mathematics. In Spanish, she scored an 82 and in math an 80. The overall results of the Spanish exam had a mean of 72 and a standard deviation of 12, while the mean math score was 68 with a standard deviation of 8. On which exam did Julie do better compared to other freshmen? Notice that the two exams have different means and standard deviations. The student scored higher on the Spanish exam, but we need to account for the math exam being a harder exam. We can do this by comparing the z-scores. Listed here is the calculation for the Spanish z-score and the math z-score. Notice that the Spanish z-score is equal to 1.2 and the math is equal to 1.5. Comparing the two z-scores, we can see that the math exam has a higher value, suggesting that the student did better on the math exam than the Spanish exam when accounting for the difficulty of the two. Located in the video script is a website with additional practice problems and solutions for z-scores. This concludes the Module 8.2 video.